I think it goes without saying that we live in golden times as mobile developers. I mean, Ionic 2 is excellence in engineering that I personally love and have used on projects myself. PWAs offer yet more incredible advantages, as you have heard, to delivering the web to your users on mobile devices. Really cool and useful stuff. The mobile question these days to me is really not about what is the best option, as a lot of options out there are really fantastic. We have options to fit really all the desirable use cases and conditions. To me, the question always comes down to what your end goals are with your particular project and what exactly you're after. So today, more than ever, I feel it requires knowing yourself, your team, your market, and your boss's vision more acutely than ever before. So before we explore another mobile option, what the heck do I know? First of all, I'm a developer just like all of you, faced with likely the same difficult choices every day, trying to make solid decisions for various projects I work on. Which, by the way, I work with a design and development services company, Tryon Creek Software, based out of Portland, Oregon, where we work on a myriad of different projects, all with different needs. Since every project is different and often does not result in the same choices, understanding those choices thoroughly is a must. Close to 2 years ago now, NativeScript popped on my radar. And there's 5 things in particular that jumped out at me, and I would consider them the 5 things you should know about NativeScript. Number 1, native UI for iOS and Android. This is really one of the 2 differentiators from Ionic and PWA, which both use web UIs based on the DOM. There's no web UI, meaning you don't use HTML markup to build our views. Rather, we use XML, which the NativeScript framework has abstracted to equate to native view components on iOS and Android. Having developed Objective-C iOS apps directly with Xcode in the past, I was very familiar with the difference between a web UI and a native UI. Number 2, direct access to native APIs right from JavaScript and hence TypeScript. This is the second differentiator from Ionic and PWA. It's also what uniquely sets it apart from React Native. 3, sharing code between web and native mobile projects. Since number 2 was particularly drool-worthy to me, it led directly to my excitement about sharing code from the web to these native mobile projects. From writing in Xcode in the past and developing native apps, the thought of sharing all the same business logic across the web apps with these native mobile projects was something that was always desirable. So this was very exciting to me. Number 4, Angular integration. And this is really what makes number 3 possible. I really love Angular. In fact, I've loved Angular from way back in the pre-beta 1x days. This is around 2009-ish. So to be honest, had this point not existed, I'm not sure how deep I would have ever gone with NativeScript. I just love Angular. Number 5, it can be used without Angular. So it can be used with React or Vue.js, for example. There is some early experimentations with React, and so I think these things will come in time. But it is very flexible in that regard. And I feel it's important to reiterate, these points are not what make it better than anything else. These points are only important in understanding the options. It's really what this is about. So I think it goes without saying, I personally fell in love with NativeScript rather quickly. It was not only fun to develop with, but I found it incredibly flexible and empowering. So what about NativeScript and why? What use cases have I found it applicable and a solid choice for a particular project? Before discussing use cases, let's look at a NativeScript for Angular app first. So you would first want to install the NativeScript package globally with npm. This will give you the TNS command line utilities. We could create a project with TNS create, our project name. In this case, we'll call it Craft Tyrol, and we'll pass the --ng flag. This is what's going to pull down a NativeScript Angular template specifically. If we take a look at that setup and look inside, we'll see largely Angular files here. We have a standard app component, our root module. We've got a routing module here that sets up routes the same way you would normally set them up for the web, for instance. Well, you'll notice this NativeScript router module. So there's these particular modules that come from the NativeScript Angular plugin, which is installed when you pull down this template, that overrides certain default Angular modules. And this is what wires into the native mobile routing. So we'll see that our starting component starts with this items component. And if we take a look, you'll see NativeScript XML. So again, this is not HTML like the DOM, but this is this XML markup that abstracts iOS and Android native widgets here. We can run this project on iOS with TNS run iOS and emulator. This will run it on the iOS simulator. And we'll see our app here, which allows us to dive into each item and see a detail view and navigate back. I want to demonstrate native API access though. Let's add a component to this view. I'm just going to add a slider, min value of 0, max value of 100, and we'll set the value initially to 50 here. If we run that, we'll see a native slider here, as you might expect. Let's add a directive that might tap into the native API of that slider component. We'll call it slider directive, and we'll drop standard directive setup here. This is going to be a slider demo attribute, and it's just going to inject an element ref here. And let's start out by just printing out what the native element is underneath this element ref. And to use that, let's just make sure we actually import this new directive and declare it in our root module here. And then let's also make sure that we add slider demo as the attribute here to see it. When it reloads, we get that it is a slider. So really nothing all that surprising here. This is a slider component, and we're just printing out the native element here. But where things get rather interesting is NativeScript's ability to provide access to this native element. So we can actually use the iOS or Android getters off these native elements. Since the native element underneath this element ref actually points to a NativeScript view component, we can use this iOS getter to get access to the underlying native class. So if we actually look at what that is, we can see it now prints out UI slider. This is in fact a class that we can pull up on Apple's docs and look at the entire native API of this class. And we can code right against this API. So for instance, let's say we want to actually change the thumb image to be something else. We can see this set thumb image for state. And so we can actually use that. We can create a reference to our slider, and we'll cast this to a UI slider instance. And now we actually have access to this entire API. Now I'm getting IntelliSense here because I've installed these platform declarations, which I'll show you in a moment. But just to illustrate this, let's use this API, and we'll pass in an image that I have added to my app's resources here. And in this case, it's going to be an image of Jury's profile pic. And the second argument we can see takes a UI control state, and we'll just set it to normal for its normal sitting state. Now, if we look at my app resources, I had already dropped an image called jurythumb.ping. And if we run and take a look at this now, you can see we now get Jury's Twitter profile pic as our actual thumb in our slider here. So you have completely unrestricted access to tap into the native API of these widgets. And of course, this is just scratching the surface because you can write entire libraries with some of these APIs. Another example I want to show you is, for instance, setting the minimum track image. So that would be the color of this bar right here. So we can tap into that API here, set minimum track image for state. We'll grab another UI image that we have in our resources here. This one is going to be called slider BG. And this is again going to be for the UI control state, normal. And if we take a look at that, we see that we now have this pink background as our minimum bar here. If we take a look at that image, it's actually just a pink square, and it's being stretched all the way through our slider here. So we have really powerful abilities to tap into these APIs. Luckily, some of them we don't even need to tap into because of how NativeScript handles CSS. So for instance, this minimum track image is actually being done under the hood. If we were to go into our app CSS and actually drop the background color being set to that same pink color for our slider class, which will now get applied to our slider component since this has the slider class on it, and we save and look at that, you'll see we get exactly the same look. So NativeScript actually does some under the hood native API modifications through CSS. And for other things that cannot be set through CSS, we can manually tap on the native APIs to do so. So what about Android? In the case of Android, we could actually import a Boolean from the platform module that comes from NativeScript, and we could use, for instance, the isIOS Boolean and wrap this in isIOS to tap into the native Objective-C APIs here, and then in the other side of the condition, we could tap into the Android APIs. So if we just console log out what the native class is here on Android using the Android getter off of this NativeScript slider component here, we'll see our slider here on Android, and we'll see it prints out that it is an Android widget seek bar. So just like we did for iOS, we can actually go to Android's docs and look at the seek bar. And we could go through this API and find things to wire into. So we could see that this is a subclass of this ABS seek bar. And we could, for instance, look for methods that deal with the thumb, and we can see there's this get thumb that returns a drawable. And so we can start to code directly into that API as well. So let's create a reference to our seek bar and cast it as the Android widget seek bar. Then we can see get thumb is available, as we saw in the API docs. That returns a drawable, which has a method called mutate, and that would give us the ability to say, for example, set the alpha to 0. So we could actually use absolutely no thumb if we didn't want to. And we can see it now hides the thumb, sets its opacity to 0, and we still get a workable seek bar here. And of course, you also notice that the background color is set the same, just as it was on iOS. So the CSS is applying using the native APIs on iOS appropriately, and also, of course, on Android. So this is all really pretty neat, but what if we don't want to have this conditional logic? Depending on how deep you're going with coding against native APIs and how much you're developing out unique capabilities on iOS or Android, sometimes using conditional logic is too much for one file. And so NativeScript provides an extra ability to create separate files, and you can target each platform by using the suffix of that platform. So in the case of this slider, we could also create this same thing specifically for Android using the Android suffix here, and that would just tap into our Android API. And then we could also have this iOS suffix, and this taps into our Objective-C API. And then we can use this TypeScript trick where we declare the class, and that's what we would use to import across our code base. And when NativeScript builds this, it's actually only going to grab the file, collapse the target name for whatever platform it's building against. So that way you totally exclude all of the other platform code that is not applicable on one or the other. It's a really powerful way to develop cross-platform code in your code base. So we can see that I can use that directive here in the root module and import this slim slider straight from slider directive, because it's using this declaration file that declares the class name slim slider. And then when this builds, again, NativeScript will actually just build and only use the one for the target platform. This concept can be applied to anything, even view files. So for instance, our detail component, which specifies this item detail component template, we could actually use Android suffix there as well that would be specific for Android only. We'll just put a title that says details on Android. And then even on iOS, if we omit the suffix, it's going to default to grabbing what's available. So even though we don't specify iOS, it's going to use what's available as the default, and then we'll specify on iOS here. And you can see when we run that on iOS and look at the detail, we can see details on iOS. And on Android, if we click on a detail, it says details on Android. So you can see that it is using the Android one since that was available, and then it's falling back to this one for iOS. This also applies to even CSS. So you can see how this could be very empowering and flexible. So if you install the TNS platform declarations and save them to your dev dependencies, you can set up this IntelliSense around the iOS and Android libraries. And that is what I was using to get that IntelliSense off Objective-C and those Java libraries there. Additionally, with iOS, we can also set this global TNS TypeScript declarations path and set it to just a path within our app and run TNS build iOS. This is going to generate TypeScript definitions for all of the iOS Objective-C APIs that we have access to. But what is unique about this and powerful is that if we have included third-party libraries via CocoaPods or even a framework file in our project, it will generate out the TypeScript definitions for those third-party libraries as well. And if we were to run that in our project, it would generate these two different folders here. We'll look inside i386 and we'll see these different type definitions. You can see that some of them are very long. This is the entire AV foundation, basically as a TypeScript definition file. This is what provides the IntelliSense in TypeScript. And as I mentioned again, you would get third-party libraries here had you included them in your project. Pretty neat stuff. Okay, so let's also talk about Angular CLI. Awesome way to generate a web project for Angular, and you could use ng-new. You can also drop a NativeScript app in a CLI project really quickly using this NativeScript NGX Magic library. So if we were to install that and save to our dependencies, we would end up getting the ability to create NativeScript XML files for our project here. The one unique thing about NGX Magic is we need to make sure that we use the component decorator from the library here. So this is going to be from NGX Magic, and then we need to make sure our components use the module metadata, and we're going to remove this relative path. And now we are free to create NativeScript view files. So this could be appcomponent.tns.html. And then we would also create, since this specifies a CSS file, we could also create app.component.tns.css. And this would be for our NativeScript style. Here we'll just drop an action bar. We'll call it CLI app. And we'll drop a stack layout. And we'll just have a label here and call this demo. You'll know that NGX Magic installed if you see this graphic display in your console. And then we can run our app with npm run start.ios inside of our CLI project. And this would boot up a native iOS app that was created very quickly just by dropping NGX Magic into our CLI web project. And there we see our native app with the CLI app action bar, and we have our demo label. NGX Magic uses a component decorator to handle the template switching when you run it on the web versus when you run it in a native app. This has pros and cons. It is easy and it will get you up and going with NativeScript quickly and sharing code. The downside is that AOT does not work with custom decorators. So if ahead of time compile is important to your project, then these component decorators are not going to do you justice. So in addition to that Angular CLI plugin, there's also the Angular Seed Advanced, which I've worked on for quite some time, which does not use custom component decorators. It actually uses a combination of clever gulp scripts to copy the correct templates into place when you run the iOS or Android app. And it is a powerful setup with a lot of features out of the box, including NGRX, analytics integration, and internationalization features, as well as Lodash. It also allows you to code against Electron for desktop. Jen Looper, another NativeScript expert in DevRel for Telerik, also has provided a much simpler version of the advanced seed called Angular Starter, and I definitely recommend checking this out if the advanced seed is a bit too much. It offers a lot simpler setup out of the box. So what are some of my use cases for NativeScript? I want to just first say this is not a guide by any means, but just sharing my personal process. Number one is, does the boss have an affinity for native mobile UI? I've come across this quite a bit. Sometimes there are very particular bosses that are aware of native UI versus web UI, and they particularly want a native mobile UI. This first and foremost takes precedence with any project. Also, will the app's audience have predominantly Android or iOS user base, hence not as much or any at all desktop web? Sometimes you'll come across an audience that's going to use this app that only uses tablets on Android or iOS, and sometimes they will be a little more particular and sensitive to the differences between a native UI versus a web UI that you may find in a hybrid. This is also a great use case for NativeScript. Is the project going to require any mobile CPU-intensive operations and or background processes? This is something I've come across as well. You can queue up NativeScript on a worker thread in the background and do intensive work in the background, even when the app is placed in the background. This is also another really good use case for NativeScript. Does the project require native hardware integration? Something else I've run across is you'll have a native hardware piece, say like a Raspberry Pi, that you want to integrate with different sensors, let's say temperature, humidity, and you want to be able to access and talk to that native hardware. Oftentimes that hardware only exposes native APIs through Objective-C and or through Java. This is another great use case for NativeScript. Does the client just want a native mobile app? I've seen this before where they just specifically want a native mobile app. Again, they're kind of like the boss where they are a little bit savvy and they just specifically want a native mobile app, not a hybrid. And then if none of the above apply, I'll just use what I feel like building at the time and what I can build most efficiently with. And personally for me, this is often NativeScript these days. Let's look at a couple performance resources. We wanted to have a React Native speaker in this lineup, but we were not able to secure one at this particular time. So I'll just share a couple things that compare the two. First of all, the difference between React Native and NativeScript. There are tons of differences. Both deliver really great performance on both iOS and Android, providing 60 frames per second most of the time. There's still scenarios that needs to be polished in both frameworks, but even today they behave as truly native apps. Technically speaking, with React Native, they calculate changes that need to happen to the UI on a background thread and apply those changes in batches. There's pros and cons to that approach. On the positive side, the UI thread's not touched, but on the negative side, this is limiting their ability to communicate fast with the underlying native OS. This means that if you have a component that makes a lot of calls to native OS, the app could be slow. And the good thing is that this is not needed for most cases. However, the bad thing is that if you do need to use custom native components or APIs, you would need to know Objective-C for iOS and Java for Android to access these components and APIs. Here's a high-level diagram of kind of the structure with React Native, and you can pay attention to the center part. That is this bridge. It's an asynchronous bridge that serializes the payload and then deserialize it on the way back. And the native layer there is the events and the native UI, and everything communicates through this bridge back to the JavaScript JVM. Technically speaking, with NativeScript, on the other hand, it uses the UI thread to execute the UI, which is the same model used on most platforms, Android, iOS, and even the web. This allows for a simple way of developing apps. You as a developer always have access to the UI tree of your app. As I showed with the slider example, we had complete access to customize all of its behavior right at our fingertips. Some of the core components like HTTP, image, SQLite database perform a lot of their operations on a background thread to reduce the load on the UI thread. It's important to note that there aren't any wrappers for native APIs in NativeScript. This makes the whole experience quite elegant and arguably less error-prone. And what do I mean by error-prone? It's not to say that the others are actually error-prone at all, but comparatively speaking, when you're talking about Cordova or React Native that do have a bridge, you're calling a wrapped API, hoping the underlying call is correct and up to date. And if it's not up to date and crashes your app, it does require you to contact the author or open a different IDE to make those corrections to the native code and then update that plugin or bridge to where you could access that. Whereas in NativeScript, you just make the change and keep developing with no disruption. Here's a high-level NativeScript diagram where you can see the JVM on the bottom, and this communicates through this marshalling layer to the native API. And the marshalling layer consists of this metadata generator, and that's similar to what we did previously where we generated all of the TypeScript definitions. And that's how we can see what exactly the types of those codes are when we communicate with the native layer. And then this runs a type conversion process and hits a call dispatcher to communicate. You can do multi-threading in NativeScript with familiar workers, just as you would on the web. You can spin up a worker and do work in the background in that worker and then communicate back to the app. Again, similar API on the web. So just a few learning NativeScript resources, Egghead.io. I've got an intro course that is good to get up to speed with NativeScript for Angular. A brand new course that just landed today on native API access. It goes deep into writing Objective-C, Swift, and Java API for NativeScript for Angular. There's also some great resources on Udemy from Nick Raboy, a great course that covers all aspects of NativeScript Angular development. There's also a course on Pluralsight from Alex Ziskin that is excellent to check out as well. And as far as NativeScript in the wild, Shoutout Play is an app that I have worked on. It's available for iOS and Android. It specifically integrates with the Spotify native SDKs, and you can definitely have a lot of fun with it. It was a lot of fun to develop, but it does require a Spotify Premium subscription. Also, definitely check out the NativeScript Kitchen Sink app. It's available on Android and iOS, and it's definitely a good way to kind of look at a lot of the core components that NativeScript provides in addition to some of their pro components and get a feel for what NativeScript actually feels like. Just to conclude here, my bottom line when it comes to mobile dev choices, knowing all the options presented by all of us tonight are really important in making a solid choice for yourself and others involved in your project. And lastly, really explore, have fun, and see what you like.